So we were asked to evaluate this improper integral, and when we look at the function in the inside of the integral, it's 1 over x minus 1 squared, and when we substitute 1, we get 1 over 0. So we can see that this function has a discontinuity, and since 1 is in between 0 and 2, the discontinuity is in the interval, and it's an infinite discontinuity. So let's rewrite the integral. So we can rewrite it from 0 to 1 and then from 1 to 2, so we can break it up at the discontinuity. And since it's an improper integral and it goes to infinity at x equals 1 or negative infinity, you can tell by looking at the graph. You can look it up on Desmos or graph it yourself. So now that we broke up the integral, we can write it using the limit definition. So we have the limit as b approaches 1 from the left of the integral from 0 to b, and then of the function 1 over x minus 1 squared with respect to x. And then we can add this to the limit and then pick a new variable, so c goes to 1 from the right, from c to 2, of 1 over x minus 1 squared with respect to x. So now we can rewrite this integral, so we have the limit as b approaches 1 from the left. So now using u substitution, you can solve this integral, but for the purposes of just speeding up the video, I did it before. So we have negative 1 over x minus 1 from 0 to b. And then we can add this to the limit as c approaches 1 from the right. And then I did the u sub here, so we have negative 1 over x minus 1 from c to 2. So now we can substitute in to find our limit. So let's quickly just graph or sketch the graph of negative 1 over x minus 1. So this consists of, so at x equals 1, the limit will go to positive infinity. And also at x equals 1 from the right, it will go to negative infinity. So from the left, positive, and then from the right, negative infinity. So knowing that, we can substitute in b. So b is 1 from the left. So when we substitute in 1 from the left, we get infinity. And then when we substitute in 0, we get negative 1 over 0 minus 1, which is 1. So we can subtract 1. And then to this, we can add. So when we substitute in 2, we have negative 1 over 1, which is negative 1. And then we're subtracting. And then 1 from the right, we see it goes to negative infinity in our graph. And then we can write negative infinity. So, but a negative of a negative is a positive, so this is a positive infinity. So this is equal to negative 2 plus, it's about like 2 times infinity, but from this we can just see that this diverges. So that is the answer.